This is the second part of the alcohols topic, where we're going to look at some of the reactions of alcohols. The first set of reactions we're going to look at are the reaction of alcohols with sodium, hydrogen bromide and phosphorus pentachloride. At GCSE level, we met the reaction of sodium with water. The reaction of sodium with an alcohol is quite similar. This is where the OH bond is breaking, and when sodium reacts with ethanol, we produce sodium ethoxide. The observations are similar to water as well, in that we get fizzing when a small piece of sodium metal is added to the alcohol. The reaction of an alcohol with hydrogen bromide is a nucleophilic substitution reaction, and we produce a bromoalkane. This reaction is our first organic preparation in AS chemistry, and there is a video which is devoted to the practical details for this reaction. The final reaction is the reaction of an alcohol with PCl5, phosphorus pentachloride. This reaction replaces the OH group of the alcohol with a Cl group. It is done in the fume cupboard, and we add solid phosphorus pentachloride to the alcohol. The products that we form are the halogenoalkane, phosphorus oxochloride and hydrogen chloride gas. The observations for this reaction are that the solid disappears, we get steamy misty fumes, there is a hissing noise, and the mixture warms up. PCl5 reacts with any alcohol and converts the OH group to a Cl group. If used in excess with an organic compound containing more than one OH group, all the OH groups are converted to Cl. This reaction is sometimes used as a diagnostic test for the OH group, as white steamy fumes are observed, which turns damp litmus paper red. So far, we have looked at the reaction of alcohols with sodium, with phosphorus pentachloride, and with hydrogen bromide. The final set of reactions we are going to study are the oxidation reaction. The last part of the topic for alcohols is the oxidation of alcohols. The specification states that you have to describe the oxidation of alcohols using acidified potassium dichromate with reference to the formation of aldehydes and carboxylic acids from primary alcohols, ketones from secondary alcohols, and the resistance of oxidation of tertiary alcohols. The most important skill in this part of the topic is to be able to identify primary, secondary, and tertiary alcohols as they produce different products when oxidized. If we look first of all at primary alcohols can be oxidized to aldehydes. If we look at the equation, we can see that we don't put the oxidizing agent into the equation, but instead put an O in brackets. We will see this throughout the equations for oxidation. So the first equation shows the oxidation of ethanol to an aldehyde, ethanal, but ethanal can be further oxidized to a carboxylic acid. We can be asked to write these equations, ethanol to ethanal, ethanal to ethanoic acid, or we could also be asked to write the overall equation. If we take the two step equations and add them together, we end up with the overall equation for the oxidation of ethanol to ethanoic acid. During oxidation of a primary alcohol, if the aldehyde is required, the aldehyde is distilled off. However, if you want to oxidize a primary alcohol all the way to a carboxylic acid, we use reflux apparatus. The reason why we do this is due to the boiling points of the products. If you look at the table below, you can see that ethanal, because it does not have any hydrogen bonding, has a very low boiling point. Therefore, if we carry out oxidation using distillation apparatus, the aldehyde has a lower boiling point, so distills off before being oxidized further. However, if we look at the boiling point of the acid, you can see that the acid has a boiling point of 118. When we reflux, the aldehyde that is produced condenses back into the mixture and gets further oxidized to the acid. Secondary alcohols are easily oxidized to ketones. This is usually performed under reflux conditions as the ketone cannot undergo further oxidation. You can see from the slide the colour change of the oxidizing agent, the acidified potassium dichromate, from orange to green as the reaction proceeds. Oxidation of tertiary alcohols does not occur. If we look at the pictures in the slide, you can see 2-methyl-propan-2-ol is an orange solution, and after heating it remains orange. So the oxidizing agent is still present as the dichromate ion and has not been reduced to the green chromium 3 ion. If you look at the table, this sums up the products of oxidation. A primary alcohol can be oxidized to an aldehyde and further to the carboxylic acid. The secondary alcohol can only be oxidized to the ketone, and tertiary alcohols cannot be oxidized. What is the oxidizing agent? The oxidizing agent is acidified potassium dichromate. You will have met redox equations at Unit 1. Write the half equation for the reduction of the dichromate ion to chromium 3+. You can pause the video and try this now. The first step is to balance your oxygens, as you have oxygens in the dichromate. So we're going to need 7 waters on the right hand side to balance the oxygens. When we put in oxygens in the form of water, we also add hydrogens. So we need to add hydrogens to the left hand side of the equation. We need 14 H pluses, and this is why this is acidified dichromate ions. The fourth step is to have a look at the oxidation numbers. The chromium in the dichromate is +6 and it is being reduced to +3, and we have 2 chromiums, so therefore we need 6 electrons. If you have a look at the next slide, you can see some of the reactions we have carried out in this topic. If you want to pause the slide and see, can you write balanced symbol equations for the reactions using propan-1-ol as your alcohol. When we react propan-1-ol with sodium, we get sodium propoxide and hydrogen. When we use phosphorus pentachloride, we are replacing the OH with the Cl, so we make chloropropane, phosphorus, oxychloride and hydrogen chloride. And finally, when we use hydrogen bromide, we are substituting the OH group for the Br to make bromopropane. When we oxidize propan-1-ol, because it is a primary alcohol, we can oxidize it first to the aldehyde, and we can oxidize the aldehyde to the acid.